Hello friends, welcome back to my YouTube channel. In this video, our title we are going to discuss is one sample t-test, two independent sample t-test and ANOVA test, right? So here basically we have 5 questions. We will be using Minitab software and EViews software for these data manipulation and calculations. So first let's try to understand in which circumstances we will be using one sample t-test, two independent sample t-test and ANOVA table, right? So in addition to that we have z-test also, right? So here what we have to basically ask is if our sigma is known or not, right? So this is the first thing that you have to ask. And before that, since these are all parametric methods of data analysis, first we have to make sure that the data set is normally distributed, right? So the first thing that we have to consider is we have to check whether the data set is normally distributed or not, right? So first check for normality. After that we have to ask ourselves whether our sigma is known or not in order to decide whether to conduct a t-test or z-test, right? So here you can see first we have to ask our sigma is known or unknown, right? So if it is unknown, we have to ask if our data set is small or large, right? But if it is known, we will directly go for z-test. And if our data set is less than 30, we will go for t-test. If our sigma is unknown, sigma is our population standard deviation. Okay, right. And if our sample size is larger, we will go for z-test. Okay. Right. So under the inferential statistics, we will be having performing hypothesis test, right? So now under statistical inferences, we will be having hypothesis test, right? So now we may have three scenarios basically, right? So let me summarize over here. So the first one is we may have one sample and we may have two sample, right? So this is before and after case, and we may have more than two samples, So if we have more than two samples, if we have, let's say we have 3 groups, 4 groups, so in that scenario we will perform ANOVA test. Now here if we have one sample, our hypothesis will be, for example, let's say mu is equal to 100 and mu is not equal to 100. Okay, so this scenario our alternative hypothesis is this. This is our null hypothesis and this is our alternative hypothesis. Since our alternative hypothesis is not equal, this will be two-tailed test, right? And let's say our, right, so this is for one situation, and the other situation is our h naught mu is equal to 100, right? So if our mu is not equal to 100, either it may be greater or it may be lesser, right? So let's say our alternative hypothesis is mu less than 100. Okay, so in that scenario this will be our left tail test, right? Okay, again it may be, now this is the third scenario, our h naught is mu is equal to 100, our h alpha alternative hypothesis is mu greater than 100. So in this scenario it will be a right tail test. Okay, right. Now while performing our hypothesis test, we have to calculate the p-value, right? So now if you are using EViews software, right, so I will explain you how to derive this conclusion using our EViews software. Now our EViews software will give the probability value for this case only, right? So when our alternative hypothesis is not equal scenario, right? Now in Minitab software we can separately find the probability value for all these three situations, but in our EViews software, the EViews software will give the probability value of only two-tailed situation. Now if we find the probability p-value of two-tailed situation, now we have to derive the probability value of left tail and right tail using our two-tailed test, right? So now let's say the probability value of left tail is equal to p1. This can be computed by 1 minus p by 2. This p is the probability value that we obtain from the software for two-tail test. Okay. Again, for the right tail test, let's say the probability value is p2. This will be equal to p by 2. Again, this p is the probability of two-tailed test. Okay. Now moving to the two sample test. Now here we will have A group and B group. So what we will basically tell is mu A is equal to mu B. This is our H naught, and our alternative hypothesis will be mu A is not equal to mu B. So this will be again our two-tailed test, right? Two-tailed test. So I am just talking about this t-test, right? Okay. So again, the second scenario might be, so here also if you perform two sample t-test, the EViews software will provide the probability value, no worries. But if you consider this one, for example, let's say H naught is equal, H naught mu A is equal to mu B, and H alpha, I'm sorry, HA alternative hypothesis is mu A less than mu B, right? So in this scenario, this is a left tail test. So here again P1 is equal to 1 minus P by 2. This P is the probability that we find here. Okay, right. Again, our third scenario might be our H naught mu A is equal to mu B. At the same time, our alternative hypothesis will be mu A greater than mu B, right? So now here this is a right tail test. Here also we can find the probability. We have to compute the probability because EViews software will not directly give it, right? Because in EViews software we cannot get the probability value for this right tail and left tail. But in Minitab software we have the option, right? So for alternative we have all three options. So P2 can be calculated by this formula, P by 2. Again, P is the probability for two-tail test. Okay. So here also, let's say we have ANOVA table. Let's say we have three groups, right? So what we will write as null hypothesis is all group means are same. For example, mu A is equal to mu B is equal to mu C, and so on. And our alternative hypothesis is at least one group's mean is different from others, right? So this is our hypothesis test. Now from we can calculate the p-values, and if it is a scenario where we reject the H naught, then we have to find out which groups are different, right? So that is a different case. Now we will discuss all the questions one by one, right? So now considering our first question, let me create some space here. Okay, right. So first we have to enter the data. First we will use our EViews software. So the question says the following data set shows the height of 16 students in centimeter. test the following at 95% confidence level. The following, right? So test the following at 95% confidence level. So the things that we have to test are: the average height is different from 135. So here, based on the first question, we can write down the hypothesis. Before that, we have to check for normality. Then only we can go for t-test, right? So now I have just entered this data in our Minitest software. So let me again tell you how you can actually enter this data, right? So go to File, New, Work File. Now, since this is not a time series data, you can select this unstructured or undated, and the number of observations is 16, since we have taken 16 data values. And I can, for my convenience or for my reference, I can name this work file. So I'm going to name it as question 1, and OK. So now the work file has been created. So this is for constant value and this is for our residual values. So what we have to do is we have to create an object for entering our data. So the type of the data or the type of the object will be series. Now I can name the object. Our object is height, right? So I'm just naming it. So now here the object has been created. So I can double click on it. And in order to manually enter this data, we are not going to import from foreign files. So we can press this edit in order to enable editing. Now we can enter the data points one by one, right? So I have already entered all the data. Okay. So now what we have to do is we have to test for normality, right? So for that we have to go to View, Descriptive Statistics. We have to check the histogram and statistics, right? So in order to perform normality test, we can consider the Jacobera probability, right? So let me just insert this output into the OneNote so that I can explain it, right? Insert screen clipping. Here this is our output. Okay, so what we will do is let me erase all these things. Okay, so you can see this here. Right. So now our Jacobera probability is 0.691, right? So now don't look at this value, right? So this is the Jacobera test statistics. We are not going to consider that one. We are going to consider the probability value with alpha value, right? So since our confidence level is 95, our alpha value is 0.05. So we have to first write down the hypothesis for normality test. So this is how we have to write in the examination also. Right. So for normality, our null hypothesis will be the data set is the height data set, right? So you can mention the name set, name of the data set also. The height data set is normally distributed, and our alternative hypothesis will be the height data set is not normally distributed. Now we have found out the probability value, p value, that is p is equal to 0.695, right? So this is greater than our alpha value, which is 0.05. So we cannot reject H naught. We can't reject H naught. So at 5% significant level, we can statistically conclude that the height data set is normally distributed. Okay. Now, since our data set is normally distributed, now we can write down the hypothesis for our climb. So the first question says the average height is different from 135. So the climb is, you can see here, the climb mu is different from 135, right? So this is our climb. So this will be basically our HA, alternative hypothesis. So our H naught, now I'm going to write down the H naught and alternative hypothesis for our climb. So that will be our H naught is mu is equal to 135, and HA is mu is not equal to 135. So now what we have to do is, I have to again go to the EViews software, right? So now, okay, so you can view the spreadsheet, or otherwise anyways, right? So from the spreadsheet we will calculate our simple hypothesis. So go to view, descriptive statistics and test, and here you have to go to simple hypothesis test, right? So simple hypothesis test, right? So now if you look at this window, now we can check for mean, variance and median, and here you can see mean test assumption. Mean test will use a non-standard deviation if supplied, right? So if you know the standard deviation of the population, you can enter the value here, so that the software will provide the Z statistic also, right? So the Z statistics also will be provided by the software if you know the population standard deviation. If you don't know the population standard deviation, just keep this cell and enter our mean value. So here 135, yeah, 135 is our mean. This is what we have to check, and if you press OK, $135. Okay, right. Now here this is the popped up window for our test statistic, right? So now here you can see our hypothesis testing for height, right? So our variable name or the object name is height, and included observation. It has included 16 observations, and test of hypothesis mean. Now here the specified value of our climb is 135, but the actual sample mean is 142.75, and the standard deviation is 13.4635. This is for sample, not for population, right? So only for the 16 values that we entered to the software. Now here the method that the EViews software has provided is t-statistic, and this is the test statistic value. We are not going to bother about it for now. We will be just interested in this probability value. Since our probability value for this one is 0.036, right? So let me write down this value here. For this one, our p value is 0.036, which is less than 0.05. So we will reject H naught. So finally we can conclude that we will reject H naught. If we reject H naught, we will conclude that at 5% significant level, we can statistically conclude that the mean value is not equal to 135. Definitely, right? Because the actual mean value is you can see 142.7. Now what we have to decide is, now it may okay, so here our actual mean value is 142.7, right? So 142.7. let me write down it over here. Our actual mu, right? So let me take it as mu naught is equal to 142.7. So this is basically mu is greater than 135, right? So when we compare our specified value, it is greater, right? So the probability of this one should be greater, right? It's greater than 0.05. Okay, right. Now we have to confirm the average height is greater than 135 or less than 135. This is what we have to find out in the second and third part of this question. So let me first write down the hypothesis for our second part, right? So we have to accept, right? So according to the actual mean value, we have to accept the climb given in the second part of the question, right? So let me write down the hypothesis for that. So our H naught, right? So HA, right? So according to our climb, HA, mu is greater than 135. So our H naught may be mu is equal to 135. No worries, right? So now this is a right tail test, right? So right tail test. Unfortunately, we cannot use our EViews software for finding out the probability value for right tail test. But since we know the probability value for this one, we can calculate it using the theory that I already explained, right? So now the new probability value will be P by 2, right? So that is equal to 0.036 by 2, that is equal to 0.018, right? Okay. Now you can see our probability value is less than 0.05. So what we will do, we will reject H naught. So if we reject H naught, we have to accept our climb and conclude that we can statistically, hence we can statistically conclude that the mean height, right? So this is basically the mean that we are referring to. This mean is the population mean, right? So height is greater than 135. So this is what we will conclude based on the probability value. Okay, right. Now let's try to find out this probability value using our Minitab software, right? So I have already entered the data in the Minitab software. I hope you can enter the data by yourself, right? So here what we have to do is we have to go to stat basic statistics. Here you can see one sample z test and one sample t test, two sample t test. But for this case, since our n is less than 3 and since we have not known the sigma value, we will use this one sample t test. So here right, so the variable that we are going to find is height, and there will be no change in here, right, because we are not going to find the hypothesis testing for the summarized data. We are going to find out the samples in each column, right? So for all the data points, and hypothesis mean will be 135. Okay, so perform hypothesis test. First you have to tick this box, and this cell will be enabled to enter the value. So now we can go to the options, right? So our confidence level is 95, right? So if it is 99, you can change it, right? And our hypothesized mean, right? So let's find out the probability for the first case where we have not equal scenario, right? So here, okay, if you type okay, if you press okay, you can see the probability value here 0.036, 0.036, right? I hope you can see my cursor point, 0.036. Now again we will go to, now we will perform the t-test for the second scenario. So go to basic statistics, one sample t-test. Okay, right, so the same thing, but under option we have to change it, right? So our alternative hypothesis is mean greater than the hypothesized mean, right? So which is our specified value, right? So in the claim, right? So here okay, okay, right. So you can see here the probability value is 0.018, 0.018. Okay, right. So again you can see here our null hypothesis and alternative hypothesis also, right? So mu is equal to 135 and h1 mu is greater than 135. Okay, now here you can see we have concluded this, right? So again if you consider the third scenario, here again if you use EViews software, so you just go to this EViews software. Now if you go to this view and descriptive statistics, simple hypothesized mean, now we do not have any option to check if we want to or to alter whether to consider the not equal or greater than or less than any scenario, right? So we do not have any option here like we have in the Minitab software. So now what we have to do is, using the probability value that we found for this case for two-tailed test, now we can find out, right? So now we will move to the third question, right? Third one, the average height is less than 135, right? So for this case, now we will try to write down the h0 and ha. h0 similarly mu is equal to 135, ha, so according to our claim mu is less than 135. Okay, right. So here we cannot find the probability using EViews software, but we can calculate from the p-value that we obtained for the two-tailed test, right? So p2 is equal to 1 minus p by 2, that is equal to 1 minus 0.036 by 2. If you use your calculator, it returns the value 0.982, right? So this is the value. So since this is greater than alpha, we cannot reject h naught, right? So we cannot reject h naught, so we will we cannot reject h naught, means we have to accept it, right? So here we will reject our claim, right? So this is not we are just rejecting our claim and conclude that our mean value is equal to 135. Okay, right. Now we will try to find out this probability value using our Minitab software. Again, if you go to this stat and basic statistics, one sample t-test, so here under the options we have to change the alternative hypothesis mean less than hypothesized mean. Okay, now you can see here the probability value is 0.982. Okay, okay, so far we have discussed the first question. Now we will move to the second question, right? So in the second question we have been okay, so now in the second question, since we have three groups, we have to perform ANOVA test, right? So skipping the third question, now we will go to the third question. Okay, right. So in the third question we are supposed to perform two sample t-test, right? So actually paired sample t-test. Okay, right. So because yeah, okay, two sample t-test. Okay, right. So a question: a health management firm has sample of satisfaction rating from former patients of two hospitals and wants to know if one is rated more highly than the other. Okay, the information will be used to refer patients and to make suggestions for hospital improvement. So first we have to check if these data points are normally distributed. Okay, for that first we have to enter this data into our EViews software. So go to file, new work file, and this is not a time series data, so unstructured and undated. The number of observations 1 2 3 4 5 6 7 8 9 10 11, right? So in each group we have 11 observations, so here 11, and I will name this work file as question 3. Okay, now I have to create objects, right? So new object, but the object is for A, right? Okay, and I will open this, oh no, this one, A, and I will enable edit, and I will enter all data points one by one. Okay, so for the third question, okay, so 81 77, here 81 77, 75 74, 86 90, 62 73, 91 98, 79. Okay, and again I will go to object in order to create another object called B, right? Okay, B. Now I will open this B and edit it. Okay. 89, 64, 89, 64, 35, 68, 69, 55, 69, 55, 37, 57, 37, 57, 42, 49, 59. Okay. Now I have to open these two variables as a common group. So right click, open as a group, right? Now I have to perform this descriptive statistics, right? But if you select this common sample, it will consider common sample and individual sample. If the number of if the sample size is same for both groups, you can use common sample. If the sample size is different for each group, you better select this individual sample. But if the number of sample size, if the number of observations in each group is equal, then you can use any of these, no worries, right? So I can use common sample. Okay, so you can see here, this is the Jacobara probability. So here this is greater than, you can see here, this is greater than alpha value, and this is also greater than alpha value. And the observations, the number of observations that the EViews software has considered for both sample is 11, because they have 11 observations under each category, right? So here, since probability value, Jacobara probability, right? So don't look at this value 0.14334, just look at the 0.93, right? So this is greater than alpha value, and this is also greater than alpha value. So we can statistically conclude that what can you conclude? Okay, so if this is p value is greater, we cannot reject H naught, right? So now Jacobara probability is used for normality test. So if we cannot reject H naught, we will conclude that the data set is normally distributed. Okay, right. So now after finding this, now we can view our spreadsheet. Okay, now what we have to find is let me go to this one. So what we have to find here is, okay, so let me write down. So first we have to conduct this normality test. So from that we have identified that the data set is normally distributed. Now our H naught is and H alpha is what? Okay, so now our H naught is mu A is equal to mu B, and our alternative hypothesis mu A is not equal to mu B, right? So this is for two-tailed. Our EViews software will provide only two-tailed probability distribution, right? So now what you can do is, you have to go to view, descriptive statistics, common sample. Okay, after finding this, now again go to view, descriptive statistics. Oh, I'm sorry, because we have to find test for equality. Okay, I'm sorry. Right, so in order to find the hypothesis testing, if we want to check the mean values for these two groups are equal or not, we have to go to this view, right? So you can see here test for equality, click on that, and test for equality we have to consider if the mean of these two groups are same or different, right? And if they are paired sample or if they are common sample, if the sample size is common, you have to click this common sample. Okay, right? Now here it has returned this value. So here, since the number of n, simple n, is less than 30, right? So here you can see the probability value is 0.017. Okay, so here I have just changed this data set. I typed 61, but it is supposed to be 91, right? So okay, now let's again calculate our descriptive statistics common sample. Okay, so you can see here the probability value. Okay, so the actual probability value should be 0.944, and for the sample B it is 0.837. Now again we have to conduct this test for equality. So test for equality mean, right? So now we have to find out whether mu A is equal to mu B or not, right? So here common sample, tick on that. Okay, so you can see here the probability value is P is equal to 0.004. Okay, so here for this P is equal to 0.0004. There's the 3 zeros. Yeah. Okay, so here since p value is less than alpha value, we will reject h naught, right? So if we reject h naught, so we will consider that mu A is not equal to mu B, right? So under two-tailed test, okay, now if this mu A is not equal to mu B, our alternative hypothesis, right? So under one-tailed test, so our HA might be mu A less than mu B or mu A greater than mu B, right? So this is the mean response, right? So here this is the mean response of hospital A, this is the mean response of hospital B. So if we want to find out which hospital is best, we have to find out whose mu is greater, right? So if mu A is greater than mu B, right? So if we accept this claim, we will say that B hospital, B is best. And if we accept this claim, we will conclude A is best, A hospital is best. So we will conduct our probability, we will calculate the probability value for this one. For this, using our EViews software, we cannot find the probability. So what we will do is simply mu A, right? So here, as I discussed earlier, this is less than, right? So left tail. So for left tail, probability value can be computed using this formula. So P1 is equal to 1 minus P by 2, and here P2 is equal to P by 2, right? So here this is equal to 1 minus 0.00024 divided by 2, and here this is 0.0004 divided by 2 is equal to 0.0002. Here 0.998, yeah, 9998. Okay, so here you can see the probability value is less here. So if the probability value of less here we will reject the null hypothesis and accept the alternative hypothesis. So here only we will accept our claim, and from this we can conclude that A is the best hospital. But here we will we cannot reject H naught. Why? Because here the probability value is greater than alpha value. So we cannot reject H naught. So we have to accept that. So it will say again they are not equal. So we cannot accept this, right? So there is no evidence to accept this alternative hypothesis based on the probability value. So from this we can tell that mu A is, since mu A is greater, A hospital is the best hospital. Okay, right. Now we will move to the third question where we can find the ANOVA table. Okay, and here we will just try to, using the knowledge that we have acquired here, we will, okay, so before that let's try to get this probability value and this probability value using our Minitef software also. So let's enter these values, right? So here let me type A here. 8177, 8177, 75, 74, 86, 90, 62, 73, 91, 98, 79. Okay, and here I will enter the values for B, hospital B. 8964, 3568, 6955, 3757, 4249, and finally 59. Okay, so now we will go to the statistic. Okay, so here we have to select these two sample t-test, right? So the samples A and okay, so let me go to this assistant menu. So assistant menu, hypothesis test, one okay, so here I have to seek help for two sample t-test. Okay, so this is what I have to find out. So our sample 1 is A and our sample 2 is B, right? And is the okay, so what do you want to determine? So it is asking what do you want to determine. Okay, so let me just okay, so what I want to determine is the mean of A less, okay, so if the mean of A is greater than the mean of B, is this what I have to find out? Let me see it. So I have to, okay, let's say yeah, so my probability of this mu A greater than mu B was 0.002, right? So I will consider this one, and our alpha value is 0.05, right? So now, okay, now I have to obtain the probability value for mu A greater than mu B. So in that case, I have to select this one. So this is what I have to determine. Is the mean of A greater than the mean of B, right? So here this is optional, and each sample in its own column. We are not going to, both sample are in one column, no, each sample in its own column. Okay, so here the probability value it has not given the probability value. Anyhow, you can see that this is the mean test. Is A greater than B? This is what we have to test. But below this diagram, you can see the mean of A is significantly greater than the mean of B, because the probability value is less than 0.05, right? So it is not directly giving the probability value, but it is giving the conclusion directly, right? But P, right? So this was 0.05. Anyhow, we can find out the probability by manual calculation. So here this is the mean test. So what we wanted to test is whether A is greater than B, and for that test the probability is less than 0.05. That's what we already found out using manual calculation, that was 0.02, right? So since P is less than 0.05, we can say that the A is significantly greater, the mean of A is significantly greater, so we can conclude that the hospital A is the best. Now again we will do it for the other way around. So hypothesis test, help me on sample 2 test, is mean of A is less than the mean of B. Okay, let's calculate it, right? So at alpha, okay, that is okay, and here okay. Now you can see here, this is the mean test. Is A is less than B? Is A is less than B? So if you calculate that, the probability value was 0.998, which is greater than 0.05, which is our significant value. So the mean of A is not significantly less than the mean of B, right? So but this is not directly giving the probability value, but using our confidence interval, we can come to a conclusion. Anyhow, this is what we have to look at. Mean test, is A less than B? So if you look at the sentence below this diagram, the mean of A is not significantly less than the mean of B because P is greater than 0.05. Okay, right. So with that idea, we will move to the next question. Okay, so because we have already done it, right? Okay, so here now we can try to answer the 5th question. So the 5th question says, after that we will come to our ANOVA table. An IQ test was administered to 9 employees in 2 departments. The results are given below, right? So the IQ test results are given. So 43, so this is department A and this is department B. So we will feed this data to EViews. So go to file, new work file, and this is an unstructured or undated. We have 9 observations under each department, and let me name it as question 5. Okay, and I'm going to create 2 objects, department A and department B, and the object type is series department A and department B. Again I will create another object, department B. Okay, now I will select those 2 and control A, open as group. Now I will edit it and enter the data. So the data point is here. I will just enter all these values. 43, 57, 43, 57, 48, 65, 71, 49, 71, 49, 38, 69, 58. And for department B, I know 49, 56, 55, 77, 79, 57, 36, 64, 69. Okay. Now again we have to conduct this normality test. For that we can go to this descriptive statistics common sample. Right. So let's check if we get the same output for both common sample and individual sample. Yeah. Right. Descriptive statistics. If you select common sample, it has given okay, just look at the probability value 0.729, right? So 0.729. So let me first insert this here so that we can compare later. For this fifth question, this is for common sample, right? So I'm just writing for my reference. For common sample, right? So if you select this common sample, this is okay. Let me again go to this, open as group, yes, view descriptive statistics, common sample, okay, screen clipping, okay, right. And this is for common sample. Again, let's say this is for individual sample, right? Individual sample. Under individual sample, let me do it again, right? So view the spreadsheet. So go to view descriptive statistics, individual sample. Again, let me insert this over here. Right. So if you compare these two images, you can realize that these two are literally same. Why? Because since the number of data points in both samples are same, it has, so individual sample or common sample, there will be no issues. But let's say in our, okay, now let's say there is no data point 69. So if you consider this data point without having this 69, so if you use common sample, it will give the value for only 8 observation. But if you select individual sample, it will give 9 and 8 separately. Okay, so when we do any other question, we can easily understand that. Okay, so now what we have to do is, right, so try to understand now. Okay, so we have to check for equality, right? So view, test for equality, mean and common sample, right? So now here, when the number of samples in each group is same only, you have to select this common sample, otherwise we will not tick this one, right? Okay, so you can see here the t-test is 0.4257. okay, 4257. Since our p-value is greater than alpha, we cannot reject h naught. So we can tell that both are same. Both are same, right? There is no difference in the IQ level of department A and department B. This is what we will conclude. Okay, right. So now what we have to conclude is, so we can write our null hypothesis, mu A is equal to mu B, right? And H A is equal to mu, okay, H A, mu A is not equal to mu B. Okay, so since our p value is greater than alpha value, we can reject h naught. We cannot reject h naught, right? Cannot reject h naught. So if we cannot reject h naught, we can conclude that the IQ level of department A people and department B people are same, right? So this is what we will conclude here. Okay, so if it is not equal only, we have to check whether the department A has more IQ level or whether B has more IQ level, right? So here this is not necessary actually. Now we will move to our second question, in which we will perform ANOVA. We create some space here. Okay, so here since we have more than two groups, we will have to go for ANOVA, right? So this is for ANOVA, right? So first let me enter this data into EViews. So we will go for file, new work file. So this is also not a time series data. So under each category we have how many data points? 1 2 3 4 5 6 7 8 9 10 11 12, yeah. So under each we have 12 observations, and I will name it as question 2 for my reference. And now I will create objects, new objects. So I will say it as what do you call, class A, right? So class A, okay. And here I will create another object called class B. Okay, I'll create another object called class C. Right, so now I will select all these three groups with control. Now I will open as group. Now I can edit and enter all the data points. Okay. So 51 24, 51 24, 59 74, 59 74, 90 52, 90 52, 37 66, 72 76, 54 67. Okay, and under class B we have 57 62, 57 62, 45 75, 41 95, 52 62, 42 30, 77 80. And here under class C we have 69 67, 52 86, 39 34, 90 76, 49 58, 74 79. Okay, so again we had to conduct a normality test for this data set also, but I will just skip that part. View descriptive statistics. Now I have to select this common sample. So you can see here the probability value, all probability values are greater than 0.05, and I can go to this test of equality, and here I can select common sample because under each group, under each category I have the same number of data values. So okay, now you can see here ANOVA F test, right? So here F test probability value is greater than 0.05, yeah, it should be 8952. I made any mistake. Let me check the data points again. Anyways, probability, right? So okay, so you can see that the probability value is greater than our alpha value, so we cannot reject H naught. So what can we conclude here? 0.7952, yeah, 0.7952. Probability degree is 0.7952 alpha value, so cannot reject H naught. Our H naught, all the mean, all the average marks of the classes, average science marks of the classes are same, right? So that is mu A is equal to mu B is equal to mu C. So we cannot reject H naught. So we can conclude all the classes are okay. They are having the same knowledge in the science subject, right? So this is what we will conclude. Okay, right. So now likewise we can go for this third question, I'm sorry, fourth question also. Let's discuss that. Right, so in the fourth question, a survey has been conducted to check how much time a person sits on the internet per day, right? So this is a very good question, because in one group we have 1 2 3 4 5, and in the second we have 6, and in the third we have 4, right? So here two values are missing and here one value is missing. So let me enter this data into our EViews software. So I will go to file, new work file, number of observations. So the number of highest observation is, I think, 1 2 3 4 5 6 7, yeah. So I will just type that 7 here, 7, and the question number was question number 4, if I was not wrong, question number 4. Okay, so now I will create object for Delhi, I'm sorry, what do you call, Sainthamaradu, Kandy and Colombo, yeah. New object here, this is for Sainthamaradu, and okay, and again I will create another object called Colombo, okay, and another object for Kandy, okay. So now I will open all these three objects together with the help of control key, and I can now edit, right? So here ten 6 5 10 6 5 8 6. Here don't type 0, right? Because here the values are not appearing, so not applicable, right? So just leave as it is, and just Kandy. Oh, I'm sorry, I have just opened this Colombo, Kandy and residual. I'm sorry. Colombo, Kandy, Sainthamaradu, okay. Not this residual, Sainthamaradu. Now open as group, and here Colombo. For Colombo, edit. For Colombo, that is for Colombo 12 9 10, right? 12 9 10 5 2 1 5 2 1, and for Kandy 9 4 5 9 4 5 8 6 2 7, and for Sainthamaradu that is 10 6 5 8 6. Don't enter 0 for these remaining two values, because we have not taken data points for those two vacancies, right? Okay, so now let me just expand this and expand this also. This is not necessary here. Now I have to go to, again I have to check the normality also, and when I am checking the normality, descriptive statistics, don't select this common sample because the number of sample size under each category is different. So I have to select this individual sample. So if you select this individual sample only, it has returned the value for observation 6, 7 and 5. But again, if I select, just understand the differences. Descriptive statistics, if you select common sample, now you see here it has returned the value for only 5 observation. Common sample is, so in each 3 columns, the common sample size is 5, right? So this is not nice. So here go to this descriptive statistics, individual sample, so it has given the actual value, right? So the probability value of this 6 observations and the probability of value of 7 observation and for 5, right? So that's the thing. And here what you should know is now we will go to this view and test for equality, and here don't select this common sample because the number of sample size under each category or under each group is not equal. So we will test for mean. Okay, so now you can see the probability value of ANOVA, right? ANOVA F test, that is 0.4124. 0.4124. Okay, 4124. So since this is greater than 0.05, we cannot reject H naught. So if we cannot reject H naught, we will say that all the, so this is the question. Here the survey has sit on the internet, right? So now in all the cities, the average time per day that a person sits on the internet is same, right? So this is the conclusion that we can come from this test. Okay, right. So here if we consider this one, so according to the data point that I have entered, I have obtained this probability value. So do these all questions by yourself, and if you get any different answer, please let me know in the comment section so that I can modify it and upload a new video, right? So I hope I have explained the all 5 questions according to my capacity. So if you have any questions or if you find any mistakes while I'm explaining, please do let me know in the comment section, and please subscribe to my channel and share with your friends also, right? So hope you have learned something new from this video. Until I meet you in the next video, bye.